Today, Andre and I did L'Hopital's rule. Our equation, or our problem, is the limit as x approaches 0 of 1 minus the inverse of sine of x, all to the 1 over pi over 2 minus the inverse of cosine of x. To do this problem, since it is really messy, something raised to another messy problem, we can use the way of solving when we set y equal to the entire thing up there. This allows us to do this little thing over here where we set the limit as x approaches 0 to e to the natural log of y. Now our y is the entire thing up there, so in the end we'll be able to do something really cool and solve the entire problem with this little step right here. And we can further explain this as e to the limit as x approaches 0 of the natural log of y. Now, if we do take the natural log of our y, we get this. So we take the natural log of this, which allows us to get 1 over pi over 2 minus the inverse of cosine of x, natural log of 1 minus the inverse of sine of x. So now that we have that, we can take the limit as x approaches 0 of both sides. So look at this. This is exactly like we have up here. When we take the limit as x approaches 0 of the other side, we get natural log of 1 minus the inverse of sine of x divided by pi over 2 minus the inverse of cosine of x. Using L'Hopital's rule, we take the derivative of both the top and the bottom separately, and we get 1 over 1 minus the inverse of sine of x times a negative 1 over the square root of 1 minus x squared, divided all by 1 divided by the square root of 1 minus x squared. Now these two things can cancel out, and we're left with the limit as x approaches 0 of negative 1 divided by 1 minus the inverse of sine of x. So back up to here, we know what our limit as x approaches 0 of the natural log of y is, so we just literally plug it in. So we found that when we plug in 0 to this, we get negative 1. Therefore, when we plug it into here, we get e to the negative 1 power, and that would be our answer.